Good evening. Welcome to the April Tax Day meeting, and I want to thank all you. Either you all know how to fill out the extension forms, or you're all really on the time and have your taxes in right now.
9:30 this morning.
9:30 this morning. Do I hear 10? 10:30? What are we going for?
February next year.
Oh, February of next year, okay. I'm going to make it by August 15th. I swear to God, I'm going to make it by August 15th. Okay. I'd like to report that there's been over 31,000 downloads of previous talks that have been given here, so it still continues to be a very good spot. We're getting about 1,500 reviews of previous talks every month. We are recording tonight's meeting again, as we have the last couple of months, and it should be available within a matter of a few weeks. How many people here have actually looked at one of the recordings? You don't have to. You came here, of course, so it's not really important. But we do get a number of people looking at the recordings, and we appreciate being able to spread it around the world. I'd like to introduce our speaker tonight. Our speaker tonight is Christian Kurzke. Who is a fellow German. I had to tell him my name was Selmeier one time. He got his master's in computer science from Erlangen in Germany. We were trying to figure out earlier if that's the same Erlang as the Erlang distribution, and we haven't really come to a complete decision on that. But he's been very, very active over here in embedded systems and the kinds of things we're going to talk about tonight. He was the designer and the embedder of the web server in VxWorks, the Internet Suite. He went to Sun following that and developed the Java embedded server, which is part of the OSGi platform. He led the specification group that did the OSGi UPnP integration specification, and he has, since he has left Sun, been with Gatespace, which is one of the founding members of the OSGi, a spin-off from Ericsson, and a company that has just recently gotten some favorable press for creating an intelligent house in Czechoslovakia, if I remember right. I think it is right. But
I think it was in Sweden, but maybe there was another one.
There's another one in Czechoslovakia. It talked about the Eastern Union, and it talked about Czechoslovakia in particular. It's on the OSGi front page, so I hope it's right. So without any further ado, I think we're really talking about an area here where we're going to greatly expand the number of things that can connect to the net, and OSGi is really dedicated to making that a more simple and a more straightforward process. To tell us how they're going to do that, Christian.
Okay. Yeah, thank you for the introduction. And I'll try to answer as many questions as everyone has in the audience. So if you people have any remarks, questions, or something, it's a very small forum. Feel free at any point to just raise your hand, interrupt me, ask questions. I didn't really know exactly how technical and what the audience is going to be, so I have one very high-level marketing presentation, which I think I'm going to spare you people with, and then I have the technical specification overview. So before I go into the actual specification overview, I maybe just summarize a little bit what OSGi as an organization is, where it came from, what it's trying to accomplish, and as Bill already started explaining, OSGi, it's today, most people that look at OSGi see it as a way to create intelligent homes, create intelligent gateways to connect different devices. And this is one of the aspects that you can do with OSGi. OSGi stands for the Open Service Gateway Initiative, and it was started, I think it was late 99, yeah, I think it was late 99. And the founding companies were, amongst others, Sun Microsystems, where Joe Bassi, who's also in the audience here, and I worked together. He's sitting right here. He was, back then, he was the VP of marketing for OSGi, and I was working at Sun in the Java embedded server team. The other companies that were part of this was Ericsson, Oracle, I think IBM was also there from the beginning. And it grew from there on, but the initial starting point was the product from Sun called the Java Embedded Server. And this was an embedded framework for Java applications. So Java applications, embedded Java applications, back then there weren't too many. This was the time of personal Java. And what Java Embedded Server, the concept that it was designed on is to be a modular framework where you can plug in different components. It's a little bit of the architecture. For example, something you guys are more familiar with is, for example, how Apache is designed with all the different modules that plug in and communicate with each other. And back then it became more or less apparent that this framework can be used for more things than just building an embedded Java-based HTTP server. So Ericsson at this time used it in a product called the E-Box, which was a very early residential gateway type of thing. It was I always call it the intelligent Ethernet cable. It's one Ethernet cable in, one Ethernet cable out, and it runs a 486 processor with about 16 megabyte of RAM. And what they did is they put the Java Embedded Server framework on the residential gateway, and they used the capabilities of the framework to actually download new application modules onto the gateway to execute on the gateway. So the concept there was to have kind of a small embedded application server on your home gateway, so you can execute applications locally in your house. From this on, this back then, they started together with Sun to work and improve the specification, and then it became kind of an open standards body because Sun and Ericsson decided to open up this forum so that other companies can contribute and also developers can actually develop services for this platform. And they started very briefly, it was called the Connected Alliance, but then from there it more or less transformed itself into the Open Service Gateway Initiative, which was started as a non-profit standards organization to kind of maintain this. And it has grown. In the meantime, there was at one point, I think there was roughly like 80 companies, mostly companies from the, there was at a time there was like energy management companies, there was some interest on this side, but it's mostly companies around home networking right now. It's like, well, obviously Ericsson is still a part of this, Motorola is now in it, so the gateway manufacturers are in there, and there's also a lot of the infrastructure companies in there. So right now, OSGi is like, has released it's about to release the third version. The second version of the specification has been released about a year ago. And it's an open specification that everybody can go and download. There is a reference implementation which is available. And there's also products from companies like Sun, IBM, Gatespace is one of them, and others like Process who offer implementations of the specification. History of a little bit of where I come from, Gatespace. After Ericsson more or less founded, or after they started the Open Service Gateway Initiative, Ericsson spun off the group that did the intelligent home networking into a separate company that they called Gatespace. Gatespace was founded in 2000 in Sweden as a spin-off from Ericsson and a research lab called CRNT. And in 2001, we started the Gatespace Inc., which is the American side of Gatespace, and we're located up in Palo Alto. And that's when I joined Gatespace from Sun. So I've been with the OSGi from the beginning at Sun and then at Gatespace. That's where I am right now. So with all this background, I just start diving into the technical slides here and explain a little bit the background of what OSGi, how it is implemented, how it works. So the OSGi service platform, that's the core of the specification. And the platform is a component framework which is more or less designed to implement generic applications which are component-based. They are distributed over either different components or also different physical gateways or different platforms. It's designed with high reliability in mind. You don't want to have to restart your gateway. It's designed for a wide range of devices, so that's why it was chosen to be based on Java. So it's independent of the operating system and the processor. And it's designed for collaborative applications that share resources, share services. As I said, it has been created by a body of industry leaders. I think the most famous ones are Sun, IBM, who are pushing from the Java technology side, and then other companies like Ericsson contributed knowledge. And the specification 2.0 is currently available at the website OSGi.org. The other thing that I want to mention about the framework components is that it was based in, it's very different. If you compare it, for example, with other approaches, for example, the browser approach that loads applets, or the mid-P approach, what we have at cell phones right now, all those applications have been designed with the, more or less with the principle that the Java virtual machine is so you load the code, you start the virtual machine, and then you execute the code, and when the code is done, the software shuts down and the virtual machine shuts down. The OSGi framework was designed so that the virtual machine just keeps running. When the device boots up, it starts up the virtual machine, it starts up the framework, and then all the applications just get loaded and unloaded from the framework. But the virtual machine is assumed to be just up all the time. This means also you have to be very careful with not accumulating any resources. Java by itself is, I mean, it has all the garbage collection mechanisms, so it should be safe to not leak memory. Although when we implemented this framework, we found many interesting bugs in current VM implementations, because most companies don't really run a VM for weeks or months. So, but you also have to be careful to not accumulate just objects like in a hash table, just keep stuffing them in. So this is one of the differences that differentiates an OSGi framework from, for example, a mid-P application loader as you have them on your cell phone right now, or the MHP framework, the multimedia home platform. Then, other than the framework, the OSGi specification specifies a number of standard components which are expected to be useful for most application developers, and so that you can develop applications which are portable between the frameworks. You not just need the basic infrastructure, but you need also standardized services on top of this. So I will talk more to most of them here. That's just a quick overview of kind of services which exist. Some that I want to mention here specifically is, for example, the HTTP service, which is kind of the, well, sort of legacy, but it's also very useful from the old days, from the Java embedded server. So every application that runs on top of an OSGi framework can assume that there is an HTTP server service available. What actually the term service really means, I'll go into this later. It's a special OSGi. It has a connotation within OSGi, but it basically means there is an API available which allows to publish HTTP pages, which is specified. It also has the device access specification, which defines a number of services which are optional, but if the package is implemented, then that's the way how to do it. And this allows, for example, to very intelligently detect new devices and find software drivers for it. The other ones are, they become apparent as we go through the presentation. Then, okay, the design goals, again, it was, the biggest priority is it's supposed to be reliable. We want to have large-scale deployments of home gateways that are running 24 hours a day. You just can't afford to reboot 1% of them every day, because that's a lot of gateways when you have 100,000 gateways out there. It's